In this problem, we're asked to use standard enthalpies of formation to calculate the enthalpy of a given chemical reaction. So we have our chemical reaction here, and this is a small piece of what the tables of the enthalpies of formation would look like in the back of your textbook. And so whenever we have these problems, all we need to do is to calculate the enthalpy change of the reaction is just do the enthalpies of formation of the products minus the enthalpy change of formation of the reactants. And so what this would look like for this particular problem is I look and see that I have 4 moles of carbon dioxide in the chemical reaction. So I'll look up the enthalpy of formation of carbon dioxide and multiply that by 4. So I've got 4 times negative 393.5. And then I'll add to that the enthalpy of formation of 6 waters. Now I have to be careful in that I look at the states of the reactions. Here the water is being formed as a gas. So when I look at my table, I want to take the gas, not the liquid. So I'll add to the carbon dioxide 6 times the enthalpy of formation of water. And then finally, I'll subtract the sum of the reactants. And so I like to put those in brackets so that I know that the negative sign is going to be distributed throughout all of the reactants. And I have 2 moles of C2H6. So I've got 2 times negative 84.7. And then I've got 7 waters. Now if you notice, I did not include water in my table. And I didn't need to, because we know that for any element in its standard state, and here I have O2 gas, that's an element, that's the elemental form of oxygen in its standard state, so I know the enthalpy of formation of any element in its standard state is going to be 0. So I know that oxygen in this case is going to be 0, and that would be true for any element in their standard state. So the only thing we need to be careful of is make sure that we keep our signs straight. So I'm going to do 4 times negative 393.5 and 6 times negative 242. And when I add those together, I get negative 3026. And then when I evaluate what's inside the brackets, I get negative 169.4. And so now just need to remember that a negative times a negative is a positive. So I'm doing negative 3026 plus 169.4. And so my final answer is going to be negative 2857 kilojoules per mole. And it's always good to ask if our result makes sense. And this is a combustion reaction. I'm reacting a hydrocarbon with oxygen to form carbon dioxide and water. So I'd expect that this gives off a lot of heat. And I have a large negative enthalpy of reaction. So this is a very exothermic reaction, as we would expect.